Assalamualaikum students. Hope you people are good. Last time we were talking about some of the important numericals relating to the laws of chemical combination. Like we have two laws of chemical combination. One is law of conservation of mass and another is law of constant composition, or also known as law of definite proportion. In the last video lecture we discussed some of the numericals regarding these laws, how these laws are, I can say, applicable as far as chemistry is concerned. We discussed that very thing. Now today we are going to discuss one of the important topics, that's 25% chemistry, I mean to say atomic structure, is based on this theory, and this theory is known as Dalton's atomic theory. Before discussing, students, Dalton's atomic theory, let me tell you people who actually this Dalton was. John Dalton. It's a beautiful picture of John Dalton. This John Dalton, he was born in 16 September 1766, and he died on 27th of July 1844. He was actually an English chemist, meteorologist and physicist. He is best known for his work in the development of modern atomic theory and his research as far as color blindness is concerned. So first thing you people should keep in your minds that somebody will pose your question that who was this John Dalton actually? You people should answer in a jiffy that John Dalton was actually an English chemist, was a meteorologist and a physicist. He is best known for his work as far as development of modern atomic theory. And as far as atomic theory, that's why I told you people about 25% chemistry is based on this atomic theory. And his research as far as biology is concerned is color blindness. So this was something regarding the John Dalton. Let's discuss this Dalton's atomic theory. Before discussing this Dalton's atomic theory, let me tell you people what we read in the laws of chemical combination. In the laws of chemical combination, I told you people that in the 17th century, let me recapitulate what we read. The scientists were trying to find out methods for converting one substance to another substance. And during these studies of the chemical change, they made certain generalizations, and these generalizations were known as laws of chemical combination. And we discussed two important laws, law of chemical combinations. One is law of conservation of mass and another is law of definite proportions. In today's video lecture, we are going to discuss Dalton's atomic theory. So students, let's discuss Dalton's atomic theory. So students, let's discuss this Dalton's atomic theory. What is this Dalton's atomic theory all about? These are actually some of the main postulates of Dalton's atomic theory given below. Firstly, regarding this atom, let me recapitulate what we discussed as far as this atom is concerned. I told you people that this atom is actually the basic building block of a matter. And without thinking about this atom, it's that impossible for we people to discuss the matter. I told you people that around the 6th century BC, it was actually the Greek philosophers like Leucippus, Democritus and Epicurus suggested that subdivision of matter is possible. They said in their statement, we have discussed this thing, I am recapitulating for you people so as to make you people understand the nitty-gritty of this Dalton's atomic theory, I mean to say. So in the 6th century BC, Greek philosophers Leucippus, Democritus and Epicurus suggested that subdivision of matter is possible. For example, this is matter. The moment we will start dividing this matter, say if we go on dividing the matter, a stage will come when particles can't be further divided, and they call these indivisible particles as atoms. What I am telling you, that the moment we will break this matter, say if we go on dividing this matter, a stage will come that we can't divide the matter further, and they call that indivisible particle as atom. So this was the concept of atom. This atom is actually a Greek word. I must tell you that this atom is actually a Greek word, atmos. It's derived from a Greek word, atmos, meaning not cut. That means something which can't be split. You must remember, students, that this atom is derived from a Greek word, atmos. Atmos meaning not cut, that is something which can't be split. However, the ancient theories proposed by Maharishi Kanand and the Greek philosophers were based on philosophical thinking and not on the experimental work. But as far as this Dalton's atomic theory is concerned, it's totally based upon experiments, observations and experiments. So, regarding this Dalton's atomic theory, the first postulate of the Dalton's atomic theory is elements are made up of extremely small particles, and these particles are called as atoms. For example, this is element. For example, let's take any one element. For example, we have 118 elements known. 118 elements known. As far as our periodic table is concerned, we have 118 elements known. Let's take example of any one of the element. For example, this is sodium. Sodium is element. What's element, students? We have discussed this thing. Let me recapitulate what this element is all about. This element is a substance made up of single type of atoms. For example, this is sodium. This sodium is wholly or solely made up of atoms of sodium. The first postulate regarding this Dalton's atomic theory is that elements are made of, for example, this is sodium, this is one of the elements, of extremely small particles called as atoms. That means this sodium is made up of smallest indivisible particles, and we call those indivisible particles as atoms. So students, the first postulate you must remember regarding this Dalton's atomic theory is that elements are made up of extremely smallest particles, and we call those smallest particles as atoms. For example, this is sodium. The moment we will break this sodium, it will get divided into smallest indivisible particles, and those indivisible particles are called as atoms. So this was the first postulate regarding the Dalton's atomic theory, that elements are made up of extremely small particles called as atoms. So regarding the second postulate, my dear students, regarding the second postulate, my dear students, that as far as this atoms of a given element are identical in size, mass and other properties. For example, I gave you the example of a sodium. I told you people that this sodium is element. The moment we will break this sodium, the moment we are going to divide this sodium will get changed into millions and trillions of atoms. Millions and trillions of atoms. Millions and trillions of atoms. Mark my words, students, and jot it down. As far as this sodium is concerned, this sodium is made up of smallest particles, and we call those smallest particles as atoms, and these atoms of a particular element are identical. For example, if we go on dividing this sodium, the moment it will get divided into smaller indivisible particles called as atoms, and those atoms are, mark my word, student, this is very important topic here. This is actually the nitty-gritty of the laws of chemical combinations. So that's why I told you people, Dalton's atomic theory, 25% chemistry is based on this Dalton's atomic theory. So as far as these atoms are concerned, the moment we will divide this sodium, ultimately this sodium will get changed into smallest indivisible particles called as atoms, and these atoms are identical. I mean, say these are identical with respect to students, with respect to mass, with respect to size, with respect to shape, and other properties as well. That's why the second postulate of the Dalton's atomic theory is atoms of a given element are identical in size, mass, and other properties. So students, you must remember that the moment you are dividing the matter, ultimately this matter will get changed into smallest indivisible particles, and those smallest indivisible particles are called as atoms, and these atoms are identical with respect to mass, with respect to size, with respect to shape. That means they have a similar mass, they have a similar size, they may be have similar chemical and physical properties as well. So this was actually the second postulate of the Dalton's atomic theory. So atoms can't be further broken down. They are tiny, they are indivisible and indestructible ultimate particles. You people must remember, students, that atoms can't be further broken down. That's why I told you people, a stage comes that we can't divide the matter further, and we call those particular type of, I can say, particles and atoms. And I told you people, atoms can't be further broken down because these atoms are smallest indivisible particles, and it becomes dead impossible for we people to see these atoms by naked eyes. As far as these atoms are concerned, the moment I will put a drop of ink here on this whiteboard, this drop of ink contains millions and trillions of the atoms. From this you must conclude that I can say you must should come to the conclusion that this atom is a very meager particle, very bleak particle as far as this atom is concerned. That's why I told you people, atoms of a given element are identical in size, identical in mass, and other properties as well. They show the same physical and the chemical behavior, and they are identical with respect to size, with respect to mass, and with respect to shape. So students, these were actually the two. We discussed two postulates of the Dalton's atomic theory. In the next video lecture, we are going to discuss some more postulates as far as this Dalton's atomic theory is concerned. Till then, stay safe, stay blessed. Allah Hafiz, and thank you for watching this